We're fortunate enough to have them working for us at ConsuLab to do presentations like the one you're about to see. Go ahead and take it, Al.
All right. Well, it's afternoon here. I'm in Elgin, Illinois, by the way. So it's afternoon here. So good afternoon. I realize most of you it's morning. So good morning. But anyway, what I'm going to try to do is go through a little bit of the basics of CAN, and then get to the last part is going to be what the title is, Diagnostic a CAN System with Information Mostly at the DLC. Again, my name's Al Santini, and I've been involved with technicians at community college level, high school, area vocational, and aftermarket for a couple more years than I share, and more years than I want to share. I was the electrical and emissions instructor at the College of DuPage, and now I'm independent trainer with ConsuLab. If you're trying to get a hold of me or anybody at ConsuLab, first letter of first name, full last name at ConsuLab.com, and that'll get there. And again, so for me, that's asantini at ConsuLab.com. So, I don't think I have to spend any time talking about this, but except for the last part. On the ConsuLab.com, once you register with us, you can use the resources, and there's a lot of training materials there that you can make use of. What do we think we're going to do? Well, we're going to first of all talk about CAN as a communication. I mean, that's really what it is. It's a communication thingy, as I like to call it. And we'll talk about the basic equipment. And one of the things that I like about CAN is the odds are you have already in your shop what you need. That is a digital multimeter, a 2-channel oscilloscope, and a scanner. And not a code reader, but an actual scanner. So you don't need a tremendous amount of equipment to be able to teach it. Today we're going to look a little bit at low speed. We're going to wire up a typical high speed. Now I'm going to stop here and make a comment. This morning, and I always I didn't give myself a lot of lead time. But anyway, this morning I read my description of this, and I realized that my description says you're all going to wire up a high speed. Okay, well, that ain't going to work, and that's my fault. That description was for a normal class where I have 3 or 4 different of the trainer that I'm going to show you here in a little while. So anyway, we'll look at both types of CAN. We'll do the basic diagnostic testing at the DLC. And if we have some time, I've got a variety of different case studies. I'm not sure, the odds are probably not. But the case studies are all of the directives, you might say, are in the handout. So that my goal is always to give you something that you'll be able to use tomorrow. Okay, and that's really, it's a modified goal because COVID has taken away some of our ability to be able to walk out in the shop and instantly do something. And like Tim said, this is new to me. I've been teaching for a couple of years, and this is relatively new. So if there's mistakes in it, I'll apologize in advance, but we're going to try to do our best. I think what we all need to do is try to learn, and that means that we have to think, discuss, digest, and learn. Okay. Some pre-thoughts. The first pre-thought is CAN is here to stay. Virtually all 2008s have it. Now, when I'll get into a group of automotive instructors, and you can't communicate easily with me, but a lot of times, I look at somebody out there in a class and he's shaking his head no and everything, and sometimes not in front of everybody, but I'll on a break, hey, you're not really with me. Why? Well, I don't have time to teach CAN. Okay, I understand that. I understand that all of us in this field have got more to teach than we have time to do it in. That's a given. Okay, it's been that way for a long time, and it's not going to get any better. It's going to get worse. So I'm having this conversation with this instructor, and I said, well, okay, is there anything that you're teaching that's not on cars currently? Well, what do you mean? No, okay, do you teach breaker points? Oh yeah, got to teach breaker points. Okay. How much time do you put in the breaker points? Now, my attitude is, if you want to talk about breaker points in terms of opening and closing an ignition circuit, fine. There, I'm done with breaker points. Okay. And this guy says, well, I spend about a week on it. A week. Okay. How about carburetors? You spend a lot of time. We a lot of time on carburetors. Okay, get rid of some of the carburetors. Get rid of some of the ignition points, the breaker points, and bingo, you instantly have some time for CAN. CAN's here to stay. Multiple high-speed CANs became popular all the way back in 2010. Okay. So now you look at a wiring diagram for a 2014 or 15 or 16 or anything, and you realize that you've got 3 high-speed CANs, 1 low-speed CAN, and maybe even a communication bus where all communications occur. So it's hey. Now I don't know where you are, so I don't know. But my guess is some of you are in states that have vehicle emissions, and if your vehicle emissions involve mill-on or monitors, CAN is a frequent source of mill-on or of monitors that will not run. So if either one of those 2 scenarios, the mill is on or the monitors haven't run to completion, if any one of those is emission failure or perhaps a reject or whatever, hey, you have to get into CAN. Okay. Frequent DTCs, mostly used, but not necessarily. And then I got a couple of musts here. Okay. If you don't understand the basics of CAN, I know what's going to happen. You're not going to get up in front of a group of students and talk about it. So get yourself good with it. Play with it. The more you play with it, the better off you are. And I realize you got a lot of people requesting your time and a lot of things that you have to do, and this is added to it. And the fact that we're doing this remotely. But guys and gals, you have to understand the basics. If you don't understand the basics, you're going to have some difficulty answering some questions. I talked a little bit about communication equipment already. What do you need to communicate with a CAN vehicle? Well, you got to have a scanner, you have to have a digital multimeter, and you have to have a two-channel oscilloscope. That scanner has got to be reasonably up to date. So if you're using a red brick and you look on the bottom of it and you have cartridges in it, and the cartridge says 2004, it's not going to work. You have to have some scanner software that's up to date. And then from a student standpoint, you and the students should have access to a communications wiring diagram. If you have that, you're home free. Now, this is something that I've added. It's based on a General Motors TSB, came out, I don't know, maybe a year ago. They would have basically said to the dealerships, do not connect and disconnect modules unless you absolutely have to, because the average of our module connection integrity is about 5. Now, we used to have college DuPage, we had classes of 22, and I would break them into groups of 3, 4, something like that. Well, by the time the class is done, one class, the odds are my shop vehicle now has a bad connector. So that's where I really came up with this idea that we do as much as we can, if not everything, and we do it at the DLC. Now again, the DLC is made out of recycled chewing gum wrappers, so you can't be connecting and disconnecting 12-volt test lights and probing and things like that. You need a breakout box. We'll talk a little bit about that in the rest of this. Okay, so if you think you have the time or the inclination to teach CAN Bus, then I'm with you. All right, so what's CAN? CAN stands for Control Area Network. By the way, it's usually all in caps, capital C, capital A, capital N, space, capital B, small u, small s. That's the way the manufacturers write it up, and we might as well do it the same way. So what is it? Well, it's a way of connecting devices. And you have an automobile that has 8 high-speed modules. pretty low tech vehicle, by the way, but it's got 8. Okay, those 8 are all communicating one another on something like an Ethernet. They're communicating on a twisted pair or CAN bus. Okay, some vehicles will use a LIN, and I'll talk a little bit more about that a little while. Let's get a couple of definitions out of the way. When you connect a scanner into the DLC, you are connecting into the gateway. The gateway is the device that communicates with the outside world. It is also the device which is kind of in charge. So you got to think about it from the standpoint that is the gateway important? Absolutely. Without it, you're not going anywhere. Car doesn't start, car doesn't run. You can't even listen to the radio on some cars. You need the gateway because the gateway is what wakes everything up, and we'll talk about that in a little while. And it is the device which does all the communication. So again, emphasize to the students, when you plug a scanner in, you are plugging it into the gateway. The gateway talks along the bus. That's wrong. Okay, never mind. The bus is the interconnection or connection between devices. And it can be a single wire or it could be a twisted pair. The most common thing we have now is a twisted pair. First of all, why is it a pair? Well, we have data going out at such high speed, and we have all these different modules listening and talking and everything else, that a pair of wires just works better. There will be exactly the same signal on the 2 sides of the twisted pair if everything is okay. And we'll get into that a little bit also. At the end, and actually it's not in the end anymore, but these were originally called termination resistors, and a termination means the end of the system. What are we talking about? We're talking about 2 120 ohm resistors which connect the 2 sides of a CAN bus together. And we don't need to spend a lot of time discussing what they're there for. One thing you have to realize is if they're not there for whatever reason, communication is either shut down or communication is impaired, one of the 2. Okay? When I walk up to my car or you walk up to your car with the key fob in hand and you unlock the car, as soon as you hit that unlock button, a signal goes into the vehicle, into a module which is awake. And that module then sends a signal to the gateway, and then the gateway wakes up the entire car. So now all the modules wake up, and that wake up signal is something, if you can demonstrate it, it makes a lot of sense to students, and I'll show you how we can do that using a ConsuLab trainer here. But that wake up signal is absolutely imperative. If the system does not wake up, it does not go anywhere. It doesn't start, it doesn't run. You know, the customer's antenna should move. Okay? This wake up signal is 2 ways. It's a 2-way thing. The gateway says, hey, BCM, are you here and do you have any problems? Well, it's easy for the BCM to report back and say, I'm here. And then what's a problem? Well, a problem is represented by a DTC, a diagnostic color code. So the gateway is able to say, are you here? Yes. Do you have any problems? Yes or no. And that's how it works. I'm not going to go through all this. There's just a couple things I want to mention. Look at the date, the first date, 1983. Bosch introduces CAN on paper. In 87, we see the first protocol, and on and on and on and on and on. By 2008, virtually everything is CAN, even trucks. We have low speed, we have high speed, and we have some super high speeds like FlexRay. FlexRay is a BMW, and it's 10 megabits, 10 million bytes per second. Or in other words, look at it, 80 times faster than low speed. What's the future hold? Well, your guess is as good as mine, but I'll tell you what I think is happening, and it's been happening for the past 3, 4, 5 years, and it's going to continue happening, and that is we're going to see less reliance on low speed, and more reliance on high speed. So we're putting more and more and more on the high speed. And that's why we wind up with multiple high speed systems. I mean, I don't know what the max is, but it's probably going to be somewhere around, I don't know, maybe 20, 25, 30, something like that. And then all of a sudden we start seeing that the high speed, those are modules, by the way. So maybe you have 30 modules, and at 30 modules, the high speed begins to slow down. Well, we can't accept that. So what do? We start another high speed. Okay, and another one, another. So, you know, we look at some automobiles and we've got multiple cans that are out there, and that we believe to be the future. So, what are you going to teach? Well, that's the first thing. Teach communication errors. You know, had somebody come up to me and say, you know, I never knew what a U code stood for. Okay, and he was a technician, and I assume he had not been in one of your classes. Okay, they need to know communication errors. Now I get a question mark after different. Do they really need to know about all these different protocols? Remember, you're trying to find space to put CAN into a class. So you don't have a lot of time. So why spend it on things that they're not going to need to know? Just like I've been in classes where the instructor had 3 hours and he spent an hour talking about all of the different ways that CAN buses are wired. And my thought was, okay, now this is why I have this unexplained twitch right now, because I can't see myself teaching that. I can't see myself teaching protocols. When the student plugs in, that's the protocol, okay? Does the scanner read it? If the scanner reads it, then we know the protocol matches, not a problem. Do we need to teach single wire versus 2-wire? Yeah, probably, because that's what's out there. Low speed and high speed, yeah, sure, that's what's out there. Don't forget, multiple high-speed CAN networks are becoming common. Now, this is going to make it a little more difficult to teach, and one of the things you have to recognize is if you start and the student plugs into, I don't know, 2018, make it whatever you want, that has 70 modules on it. Now, one of the things you're going to teach him is to look at the number of modules and look at the wiring diagram, and the two should be the same. Well, okay, that gets really hard to do. So you need to pick something simpler. What I always tell people is, you know, when these people call up and say, hey, I'd love to donate a car, and say, you know, just a minute, and go to your other computer and look it up real quickly. If it's got something less than 20 modules, take it, fix it, put it away in a corner, and use that to teach the basics. Okay? Lin is becoming more common, and again, I'll spend time with that. A simple diagnostic procedure is imperative. If the diagnostic procedure involves lots and lots of specialized equipment that you don't have, it makes no sense. Or that they're not going to see when they get out in the field. Now, I've had guys come up to me and tell me, I don't have a DSO. Get one. I'm sorry. I mean, I don't mean to be too suggestive here, but you know, DSOs were popular in the beginning of 1990s. By 1993 and 94, we had many, many different brands of DSOs on the market. This is 2020. If you know, I would assume in schools you have at least a couple of single channel DSOs. If you don't, and you don't have a lot of money, look at the U-scope. It's an excellent scope, and we're talking $200. Okay, contact the ConsuLab or .tech, and they'll be able to set you up with them. Somewhere in that shop of yours, you got to have at least 1-2 channel, because you're going to need that 1-2 channel. Hopefully, you have more. Okay, don't forget, your shop vehicle's lifespan will only be interrupted or killed. You will shoot it dead if you connect and reconnect modules. So we take this basic diagnostic procedure only up to a certain point. And that point is going to be, okay, the next thing we do is we unplug and plug modules in. You don't want to do that. Now you can do something similar to that if you happen to have a training. What does the gateway do? Now I didn't have time to do this, but I wanted to leave this one slide in. One of the things that I will do, even with technicians, is I have 4 3x5 cards. One has SIR, one has PCM, TCM, and Antilock on it. And then there's 3 scenarios. Scenario number 1, SIR, when called, answers, I am here and I have no DTCs. PCM does the same, TCM does the same. So you stand there and I say, okay, I'm the gateway. And I can call myself whatever I want, but I'm the gateway. And the first thing I need to do when I see a wake-up signal is I need to call the roll. So, SIR, are you here? And have the student or the technician stand up and read the card. And I do that for 3 scenarios. The second scenario is one module is not communicating, and the rest of the modules see that there's no communication with one of the modules. And then the last scenario, we call the roll, SIR, person stands up, quiet, doesn't say a word. PCM stands up, nothing. TCM, nothing. Analog, nothing, which means there's been a total failure and the CAN bus system is down. This really works good, and the younger the student, the better off it is. What has to happen here? Well, communication. And in that communication, we have to indicate DTCs. And we have to indicate that they're there. I mean, this is all what the gateway needs to see, okay? And this only is accomplished if the CAN bus is functioning correctly. See, again, remember, the very first thing that CAN bus does is it wakes up. So we have signals which begin going to everything on the CAN bus. And then the gateway pings the individual modules. It does it extremely fast. Matter of fact, it pings everything all at the same time. And it waits to see everything come back. So that's all part of these conclusions. If you're going to use and you want to, you just can't, they got to know what the gateway is according to you, well then fine. Show them this diagram. This is a Chrysler, okay? Chrysler's using a tip-in module, and in that module, that's the gateway. How do we know it's the gateway? If you go up on the left-hand side, it's part of the CAN bus. If you go off on the right-hand side, it's part of the CAN interior bus. Now, there are other buses, but this is the one that's important, okay? And then it connects via the diagnostic CAN to the data link. Other than this, I don't worry too much about a gateway. Techniques I think are important here. And I think I've already given it away. Does the student need to know what module is the gateway? No, it doesn't hurt if he does, but he doesn't really need to know it. I mean, he's not going to call up, the Napa dealer and say, hey, I need a gateway for a 2017 Equinox. No, because the guy on the other end of the phone is going to go, hey, Charlie, we got another live one on the phone. I mean, they're not going to recognize that. Okay. Do we need to teach all the variations of CAN? I don't think so. I really don't. I've talked to shop owners, and shop owners say, when I get somebody from your school, I'd like them to come in. First of all, I'd like them to really know the basics. I recognize that they can't learn. They can't know exactly all the differences and innuendos of particular vehicles. So they don't need to know all these variations of CAN. What they need to be able to do is do a basic CAN bus diagnostics. And to be able to do a basic CAN bus diagnostics, you have to have a pretty good idea of what you're working on. Do we need to emphasize the use of the breakout bob at the DOC? Absolutely. Again, my favorite phrase, the pins on a DLC, just like the pins on all these module connectors, are made out of recycled chewing gum wrappers. They're not going to continue to work. So we need to use breakout boxes. Can we use CAN bus during a DSO unit? Well, there's an interesting question. Yeah, we can do CAN bus during a DSO unit. And the nice thing about it is, it's the DSO is the only real device that can communicate easily with a CAN bus. If we put a multimeter on it, the multimeter averages way too much. If you put a graphing multimeter on, it's not fast enough to be able to keep up with the signals. These are extremely fast signals. Okay. How about you? Are you able to show and tell effectively? And does the beginning student respond to your examples? I can't stress that enough. I will tell you, especially in my early teaching career, that I wound up with not enough time, and I sometimes stood in the front of a class or, a campfire group like Tim talks about, realizing that I didn't know everything I needed to know, and it showed. So, you need to play, and you need to get yourself reasonably good. If you play and if you get reasonably good, you will still have problems. Part of this is technologically oriented. Quick story, where I'm teaching at the College of DuPage. By the way, it was the largest community college in the country at that time. We had 40,000 plus students. And so DuPage County, real large community, and IBM approached our president and said, hey, we'd like to go through teaching and using computers in the classroom. Now we're talking, by the way, we're talking late 80s now, late 80s, or maybe even mid 80s. And so Hal, the president, said, oh yeah, we'll make it an institute day for the whole county. So we had thousands of teachers from all over the county sitting in our auditorium. And this guy comes out and he tries to fire up the crowd. That doesn't work terribly well. So finally he says, okay, teachers, let's see how you can use computers in the classroom. He's got this big red oversized switch. He switches the switch, nothing lights up. I mean, if you can visualize tumbleweeds rolling across the stage. This guy, apparently this had happened before because he knew exactly what to do. He put his arm on the podium and he said, teachers, there's a lesson to be learned here. If you live by technology, you may very well die by technology. So hopefully I won't die tonight. All right. In this process of explaining to a student about CAN Bus, I always start with individual data transfer. And what do we mean by that? Well, it's maybe a little bit of a bastardization of data, but what happens when we turn on the backup light switch? Well, when you close the backup light switch, the backup lights go on. Why? Because they have a ground on one side and they now have power from F1 on the other side. Same thing with the brakes, same thing with the markers. And we have a multifunction switch. And I mean, this is a very, very simple diagram, and it's obviously missing some things. And then from there, we move the students over to CAN Bus. Now, at first, the student's going to look at this and he's going to say, wow, Al said this is going to be simpler. No, this is not simple. Now, one of the things that I had in my classroom, we had an old Buick Electra 225 donated. And as we were taking some stuff off it, I grabbed the door. Now, an old Electra 225 is when we had everything in the door. I mean, you could shine the passenger's shoes off of the buttons there. I mean, there were buttons galore. You name it, and you could do it on the door. Well, that vehicle was on individual data transfer, which meant every time you closed an individual switch, you had a wire. So we brought B+ into the door, and we brought it out of the door for everything that this vehicle was supposed to do. The bundle of wires was easily an inch thick, an inch in diameter. So now with that in mind, as this becomes simpler, make off that this output module is in the door and all the various functions are right there. What do we have to do? We have to communicate to it. So what does it need? It needs power, it needs ground, and it needs signal. If it has power and ground and signal, then the input module on your left can communicate with the output module on the right. And when communication occurs, in this particular case, you can see it's CAN high and CAN low. So we've got a pretty good example here of CAN communication being capable on the CAN bus. Again, it's a twisted pair. Okay? And a couple, well, actually, let me switch over right now. Okay. When I need to zoom in on this, I will. I'll zoom in and you'll be able to see more. This is what we call our MP1918. It's a multiplex trainer. It's not a car, not by any stretch of imagination, although it does have a DOC. Okay, So we have a load panel on the bottom, a bunch of different lights, only lights. There's no horn, there's no buzzers, there's no motors, there's nothing else. It's strictly lights. We have 4 modules, and I'm going to show you close-ups of those modules. We have an instrument cluster module right here. We have an input module right here. We have an engine control module right here. And we have an output module over here. These need to communicate with one another. Now, one of the things I did in an effort to be able to make this a 2-hour class is I have wired the loads. So if you look over here, and you'll get a little better, a little more close-up, I have 5 terminals: right turn, left turn, backup, marker, and tail lights. Okay, so those are coming off the output module, and the output module has fuses on it. Okay, so let me go back to the PowerPoint. This is a close-up of what the input module looks like. A couple of things about it. You see on the right-hand side F2, 3, 4, 5, and 6. There is an F1, but it's out of the screen. By the way, I make no claims to be a good photographer. I suck at that aspect of it. So anyway, these are fuses. There's 10 amp fuses, which are off on the right side of the screen. The input module has a yellow band all the way around it, and you'll notice that there are 4 symbolic wires that have been drawn in there: ground, battery, low, and high. So what you're trying to show a student is an input module, like any other module, needs to have power and ground, and it needs to have communication capability, which is CAN, and if it's high-speed CAN high, CAN low. The blue plugs that you see there, that gives you the ability, if you're going to use this trainer, to show a student what's actually happening inside of the module. You're probably going to use a scope, but anyway, okay? We have an output module. And again, I'm a rotten photographer, so you see what I cut off at the top: black, red, green, yellow. Also, next to it is one of the end-of-line resistors, one of the 120 ohm resistors. Okay, the output module has 5 5-amp fuses, fuse F7 through F11, and you can see what they power. They power the right turn, the left turn, the backup, the marker, and the tail. So this is the output module close-up. Here's the engine control module, and you'll notice the engine control module has got some things included in it. It's got an accelerator pedal, it's got a TPS, and it's got an engine coolant temperature. This is so that it can communicate with the instrument cluster. So these 2 modules communicate really well, the engine control module with engine temperature and everything else. And again, you'll see at the top of it ground, battery, low, high. And on the left is a ground bus. So I pre-wired the ground bus. Okay, and again, the last module is the instrument cluster. Now you'll notice, and again, I chopped off the bottom of this, sorry about that, that on every one of these modules, there is yellow and green connector, which is supposed to be the high-speed CAN bus. So somewhere all of these have to connect together. That's our CAN bus junction block. A bunch of greens all connected together, a bunch of yellows all connected together. And this is how this thing's actually going to work. Okay, now let's go back and let's do a little wiring. So to do that, we're going to switch over and we're going to go to, hang with me here for just a second. Okay, that's a little bit better. And a couple other things about it. There's a power supply down here. And the power supply means you don't have to, you plug it in the wall. You don't have to worry about the battery, or is the battery charged or anything like that. Plug it in the wall. Just switch on it. 2 meters, 1 voltage, and 1's current. I'd like to wire this with you, and for some of that, you're going to wind up looking at my back, and I apologize for that. Yes?
I hate to bug you, but the mic is not the one in your headset.
Okay. That's a problem.
Just a quick thing in settings, and you should be able to pick your mic.
Quick thing in settings. Back to Teams.
Yeah. Don't mute yourself. The 3 dots. Click on the 3 dots.
This is live by technology, die by technology, guys.
Show device settings. Below.
Testing 1, 2, 3, 4.
There you go.
I like that. Thanks, Rick.
Yeah.
This is, what can I say? Okay. You know, this is new to me. I wanted to be more mobile. So I took my headphones that I use when I'm out walking, and I'm using them today. And what I just did was live by technology, die by technology. Anyway, what I like to do with a student is to say, first of all, prove the lights work. So I have them bring a negative over, bring a positive over, turn the power supply on, and a light works. Okay, so we know the lights work. So what's the next thing? Class, what's the next thing? What does a module need to be able to function? And again, you know, we don't have a lot of back and forth here, but the answer should come back: power and ground and signals. Power and ground and CAN bus. So if I take, and I'll start over here, only because I think this is the easiest one for you to see. I'm going to go up here to the battery, and then I'm going to go across the fuse F1. I now have powered that once we turn the power on. Okay? Here's an input, the input module, F2. Here's the ECM, F3. Here's the output module, F4. If you teach it this way, teach so that every one of the modules has its own power and its own ground. That just makes a little more sense in the student's mind. Okay, the next thing we do is we run a ground. So we go back, here's the instrument cluster. We run a ground. Input module. Ground. Output module. And the last one is the ECM. Now, normally speaking, you would all have your own trainer and be wiring these. So then the next thing I tell students is I said, okay, turn on the power. Now, when we turn on the power, we have, first of all, a power light. And then second of all, I'm not sure you can see this, let me block it. Okay, the input module is on, light is on, and the engine control module is on. But the instrument cluster is not on, and the output module is not on. So at this point, what I want the student to understand is that it's still not going to work. So if we go up to this thing and we say, well, let's turn on the backup light. There, backup light on. And obviously the student answer is, well, no, the backup light's not on. Why isn't the backup light on? Well, the backup lights must be missing something. Okay, here's the backup light. Does it have power? Yes. Does it have ground? Yes. So then the thing about it is it must not be getting a signal into the output module. This is a good time to also identify why these two modules have lights on. If we go up to an automobile, that car, even if it's sitting on a parking lot, will be sitting there and there will be something on. Because if we go up to the car with a key fob and we hit the key fob and the door is open, or if the door is unlocked, we go up and we open the door and the dome light goes on, something has to be there sitting, listening, and watching for what will become a type of wake-up signal. Okay? So now, why don't we have any communication here? Well, why don't we have any light here? Well, we don't have light because we have no communication. So I'm going to turn that back off. Green, yellow. If we start, now again, I realize that it's a little hard to see, but I'm just in the junction block. So then we have 4 modules. So I'm going to go up to the first module, which is the instrument cluster, and I'm going to connect a green and a red, green and yellow, excuse me. Then I'm going to go, and excuse my back. I've now put CAN bus to the input module. Green and yellow. Over to the ECM. Okay, now that's the modules. The modules are all now capable of communicating. But we have to realize that we have to connect the 2 sides of the circuit together. And there are 2 resistors. One end of line or termination resistor is over here. The other one is over here. So if I go up to the first one, green, yellow, go up to the second one, wow, wires left over. The DLC has no real function except in terms of giving the ability to communicate to the outside world and things like that, and also as a test point. The DLC also has CAN high and CAN low. So that's my last set of wires. Okay, now I got my power supply on. The student looks at it and says, well, nothing's different. Well, okay, let's turn on the backup light because it's going to work now. Oh, man. Doesn't want to work. Why doesn't it work? Conceptually, what we're trying to get across to students is the first thing we need is power. The next thing we need is ground. After that, we need CAN high and CAN low. And then if you go all the way back to the beginning, remember, what's one of the things I talked about? A wake-up signal. So something has to wake the vehicle up. We have a wake-up signal built in. So I'm going to flip the wake-up signal up, and you're going to notice a couple of things. One of which, probably relatively easy for you to see, the display lit up. CAN bus is now up. We now have a light on the input module, the engine control module, which we had before. We now have a light on the instrument cluster, and now we also developed one on the output. This system is up. It's sitting there. It's ready to function. Now, if I go and turn on the backup light, it works. Okay? So we take the student from the beginning, wire a light. Does it work? Yeah. Okay. Now, wire the modules. Does the light work? No. Put communication to the modules. Does the light work? No. Add the last thing, which is a wake-up signal. And once we have a wake-up signal, then the system works. Now, another thing, and I'm going to show you, I'm going to do this in 2 different ways. Another thing to recognize is the wake-up signal. When the wake-up signal is not there, the system will eventually go to sleep. Watch your display. 1, 2, 3, 4, about 4 or 5 seconds, and then the rest of the system goes to sleep. Every chance you get, impress upon the student, do not connect or disconnect any module when the system is up, okay? Because you run the risk of causing damage. Not 100%, between you and me, doesn't happen all the time. But if you're like me, guess what? It's gonna happen, okay? It's gonna happen in your class, it's gonna happen to the principal's vehicle or the provost or whatever. It's not gonna happen to your car, Mike, anyway. Okay, so while we have in this spot, we wanna try to impress upon students that the system wakes up for a variety of reasons. One of the reasons is, and I usually have a key fob, is you turn the key fob on. When you hit the key fob, the system wakes up because now it wants you to open the door, put the key in the ignition, or push the button or whatever, okay? But there's another thing which wakes it up, and that is anything on the car which will function even if CAN Bus is not currently awake. As an example, if we walk up to a car and we sit in the car and we push the four-wheel flashers, we don't even have a key. No key, nothing. The CAN Bus is not up. When you hit the flashers, watch what happens. Again, look at your display over here. There's the hazards, okay? Everything lit up, and eventually, this little display is a little slow, but anyway. So in other words, it wasn't a wake-up signal. It was the signal for the hazard lights because they have to be functional, and that's what actually turned on the system. If I turn that off, this is going to go back to sleep. Now, it may take it, there's your 4 or 5 seconds again, okay? And then everything goes to sleep. So there are two methods to turn the system on. One is a wake-up signal. And if you think about it, there's some real common wake-up signals. Open the door, system awake. Hit the key fob, system awake. Put the key in the ignition, system awake. Put your foot on the brake. In many cases, when you put your brake lights on, the car's lit up, okay? Because that's another thing. Here's your display coming on board. The display is slow. The lights come on much faster. So we have to get a student to recognize there are multiple reasons why vehicle systems will come alive. And when they're alive, they stay alive, sitting there listening. You know, I always use the key fob as an example. If I walk up to a car and I click the open button, and then somebody comes up to me, and we start talking, you know, and we're talking and talking and talking and talking. Eventually, that car's going to go to sleep again. Because if the car continues to draw current waiting for me to do something, we're going to run the battery down. You can't park a car overnight, let CAN Bus run all night long, and expect to find anything other than a dead battery. Because the CAN Bus systems, they can draw as much as 10 amps. Just the system itself. Because you're basically turning on all these modules. So we turn the system off, and that's where the system goes to sleep. This system is asleep now, with the exception the ECM is waiting for something, a wake-up signal, and the input module is waiting for the brake light or the hazard light. So it's got to be alive, and it'll be drawing very, very little current. Okay? All right. Let's leave this. Before I do, one of the things we're gonna get into is going to be a breakout box. Now, I'm not selling any particular breakout box, but a couple things about them. I think if you get a breakout box, get one that's got some lights on it. Okay, there's nothing better than to be able to look at the DLC through a breakout box and see a power light on and see the two ground lights on. It just makes a lot of sense. The other thing is have at least one data light, and I'll show you a very bad video that shows about that light. The nice thing about this, very, very good connector, very robust connections here. I've had this particular unit for over 20 years. It still works. I've used it on hundreds and hundreds of cars. Okay, they're good, robust connections. Do not let students plug anything directly into the DLC, except maybe a scanner. This one also has, this one goes into the DLC. Here's a connection for a scanner. And then we have a switch on the top that we turn off, and that lets the scanner only just kind of feed through without worrying about the lights or anything else. So we'll show you that in a little while. Okay, I'm going to switch back over to the PowerPoint. Okay, that's the same DLC, by the way, a DLC breakout box that I just was holding in my hand. That's an actual picture of it. Okay, here's what the various lights, let me go back here. I know it's probably pretty hard to see, but see the light there? There's a light here. There's two ground lights, power light. Okay, so that's what they do. Now, one morning, I had not slept well, so I had gotten my caffeine level way higher than it normally is when I decided to do a video. I decided to keep this, I could redo this video at any time, but I kind of like it. To me, it shows my infallibility, that's for sure. Anyway, okay. Watch the CAN. I want you to watch CAN pin 6 right there. Okay. Now I'm going to reach through the door, windows are open, and I'm going to turn on the door locks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It takes 15 seconds for this car. Now, by the way, this happens to be, I think this is a 2010 GMC Acadia. Okay, I'm just guessing, but I have a feeling that's what I did this particular video on. So that's important for a student to recognize, because we're using the breakout box to show the system is awake. Hold this up in front of the students and say, hey, look at, watch this. Even if you're on video, plug it into a car, and when you plug it into a car, turn it on and show the student that, hey, with this breakout box now shows me that the system is alive. And then you can take it from there. This allows the student also to keep track of how long the system stays awake after no inputs. Ask them pointed questions. Was the data light on when you first connected the breakout box? Answer, no. Let's drink of water here, wet my whistle. And then, okay, we use a key fob. How long does the system stay awake with no inputs? Because what we're trying to get them across is this concept. If CAN is awake, don't do anything. Now you gotta I realize that because I didn't start teaching tomorrow. I've been teaching, I taught high school, I taught community college, I taught area vocational center, and I taught trade. And I gotta tell you, they're all the same, okay? If you give a group of student technicians a vehicle, and they're all working on that vehicle, that system's never gonna go to sleep, because somebody's fiddling around with the radio, somebody else has got the key in the ignition and turning, I mean, you know how this happens. So getting this across is something you want to do in a classroom situation. The other thing, and I think this is a pretty neat story, is there's a story about a guy who buys a brand new car, and 2 days or 1 day or 2 days or 3 days later, he calls the dealer and he says, my car is dead. And they said, oh, we're terribly sorry, we'll send a tow truck. So they send a tow truck and they bring it over and the battery's dead. So they, charge the battery and go through some testing, charging system, everything else, everything's fine. And they put a driver in a car and they drive the vehicle back out to the guy. The next 2 days later, the guy calls and says, my car won't start, the battery's dead. So at this point in time, they decide to send a tech out to the car. So he gets out there and he looks around and he realizes that sure enough, the battery is dead. He jumps it, car starts, car runs, everything seems to be okay. And then he asks the customer, he says, now this is a push button start, push to start. What do you do with your key fob? Well, I hang it right here. Right next to the driver's door in the garage, there's a nail sticking out of the wall. And when he gets out of the car at night, he hangs his keys, even though there is no key, he hangs his key fob there. Well, guess what? It's right there. It is so close that the system on that particular car never went to sleep. So once they got him to take the key fob inside the house, everything was fine. Okay? Breakout Bob protects the pins. Those indicator lights are really important. And you know, you gotta do more than teach them look just for DTCs. Again, I had an instructor tell me once, he said, well, you know, I don't have time to do anything. So what I do is I make sure that they know how to pull codes. And they know what a U code is. Okay, but they can't do anything else. It's interesting. Okay, so this is something that I would do if we were in groups, turn on the turn signals. And one of the things where these trainers are kind of nice is, you know, if you tell them, I want a right turn signal on, and you quickly look around the room, you got right turn signals on all the way around. It means people know what they're doing. Everything's wired right. There will be somebody, some group, someplace where you will look over there and they will have nothing. And then you'll come up to it and you'll say, wow, this thing's got a lot of wire. And it's difficult. I'll be the first one to tell you, it's really difficult to stand in front of a wired trainer and trace wires. It's really tough to do. But here's what I do. I start at the modules. Power, ground, signal, signal. Trace those. 4 modules. DLC, power, power, ground, signal. Okay? Turn on a power supply. Do we have power at the DLC? Do we have, you know, everything else? And then work it from there. But a lot of times, all it takes is to have 1 wire or 2 wires out of place, and, you know, it doesn't work. Okay? And then when I go through this, and you can, rather than talking about it, I did it. I was live when we did it. Okay, let's zero in on a simple 1-wire low-speed system, and then we'll do a simple high-speed system. We start, and we have to recognize that there's battery in the DLC. So what pin is its class? It's pin 16. If you have power in the DLC, you will also have ground in the DLC. And that ground goes to, in theory, 2 separate grounds. But I'll be honest with you, in some cases, they're banded together somewhere in the car and they wind up with 1 ground. It's been done all the time. You have to have power in pin 16 and ground on pins 4 and 5 for your scanner to work. If you plug a scanner in and you get no communication, get a multimeter out and make sure that you have power on pin 16 and then you have grounds on pin 4 and 5. Okay? Now, let me go back to this. You will notice we have, starting at upper left, we have a radio, and we have an instrument panel, a remote control door lock receiver, et cetera, et cetera. If you look at these, you realize that most of them they don't have to be lickety-split. I mean, remember, this is the communication end of it. So, I mean, the heated seat control module, is it really important that it's instant on? No, it doesn't have to be on a high speed. It's okay for it to be on a low speed. Most low speeds are a single wire, and that single wire goes out to a bus. And when we use the word bus, what does that really mean? It just means everything's connected together. In this particular case, is this CAN? Yes, it's low speed CAN, and it's single wire CAN. Okay, if we take a look at a 2-wire CAN, there's a couple of things to recognize about it. The first thing is, it will have 2 data link resistors, which may or may not show on the wiring diagram. Now, if you're going to use a wiring diagram to teach from, don't use Fords, because most of the Ford wiring diagrams do not show the data link resistors because they have them in the modules. This one shows in the lower left-hand corner that 120 ohm resistor is sitting out somewhere. Do we know where? Well, no, we'd have to use a component locator. And by the way, it can also be in the fuse box. There are a couple of Buicks on the road and a couple other cars too, but Buicks primarily, that have in one of the fuse boxes a 120 ohm resistor. So when the student comes up to you and says, hey, Al, I need a 120 amp fuse, you know he's in the wrong spot, okay? And obviously, if you put a fuse in there, the fuse isn't going to blow, but what you've done is you've connected the two sides and you have had an impact on data communication. The other thing is you probably will not have any monitors run, okay? Notice up at the top, notice up at the top, we have the data link connector upper left, pin 6 and 14. Right below it, see the number 9 on what looks like a wire that doesn't connect to anything? Excuse me. That is the symbol for twisted pair. So everywhere on this car, where the high-speed CAN is, we have a twisted pair. It's probably easier to say where we don't have CAN than it would be to say where we do have CAN. Because literally, on a modern automobile, pick a spot, you will have CAN in it. There's CAN in the back of the dashboard. There's CAN under the seats. There's CAN under the carpet. There's CAN in every door. There's CAN in the headliner. There's CAN in the trunk. And there's CAN under the hood. Now, this makes it easy and hard. What makes it the easy part is CAN's everywhere. So the manufacturer is the one that gets the benefit of it being easy. He gets the connectings anywhere he wants. This also, you know, you can take a customer who did not buy auto start, and it can be added to a car. How is it added? It's added very easily. We give the person a new key fob. We reprogram the key fob module or vehicle communication module, and we connect that module to the CAN bus. Bingo. We just put auto start on. Okay. These data link resistors can be out in the open, in a module. Here's a case where both of them are in modules. One's in the body control module at the top, and the other one's in the powertrain control module on the bottom. Notice on this particular diagram, we still show power to pin 16, although they got rid of the fuse. Okay, so according to this, the HVAC control battery fuse 10 amp looks like it's inside of the body control module. It really isn't. It's in the power distribution center. And then we have the other 120 ohm resistor, which is in the PCM, which is about in the middle of the screen. This also shows that we have our power on pin 16, our data on 6 and 14, and we also have grounds on pin 4 and 5. And we also have something here on pin 2, which is class 2 serial data, and I'm not going to go into that. We just don't have enough time. But that's another type of CAN. It's not exactly CAN. Instead, it's called class 2 serial data. But anyway, okay. Now, I'm going all the way back to 2011. And the reason I'm going back that far is cars were a little bit simpler. There were less modules. If you count across, you realize you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 modules on the top line, and 1, 2, 3, 4, 5, 6, 7, 8 modules on the bottom line. The two of them are connected together all the way on the right-hand side. And again, if we go and we look at a DLC, is this information available in the DLC? And the answer is yes. This is more of a diagram as to how they're wired, not how they're communicated with. Okay? The high speed, like we've looked at before, uses twisted pair, and you'll notice right at the very upper left, 120 ohm resistor right there. Okay. Now, just briefly about linear interconnect, or LIN. The first thing to recognize about LIN is it is not in the DLC. So in other words, look at the modules in the lower left-hand corner of the screen. 3 of them: rear differential, fuel pump, EBC. They go up to the body control module. Well, now wait a minute. Al, what are you saying? I'm saying these 3 modules do not have a direct communication line because they're not connected to CAN bus. They are instead connected to the body control module, which is connected via CAN bus into the rest of the system. So LIN is a way for the manufacturers to say rear differential, fuel pump, and EBC do not necessarily have to have their own CAN bus line. Sure, they need power, sure, they need ground, and sure, they need some kind of a signal. Well, where's that signal coming from? It's coming from a BCM, and it's the BCM that's connected into the CAN network. Now, if I've confused you, good. No, I just kidding. If I've confused you, I'm sorry about that. But LIN is not terribly complicated. The main thing to remember is when you're talking about LIN, okay, it's an item which is usually not in the DLC. So you can't look at the DLC and say, oh, there's the LIN. No, it's not there. Usually there's a B+ or ground switch from a CAN module that is, and is made red on purpose. So it's in the network and it supplies power to the module or whatever, okay? So the sequence here, something wakes up the gateway sends out a wake-up signal. CAN comes alive. Once CAN comes alive, LIN is turned on, and it now begins talking to the module that turned it on. And everybody starts talking, and hopefully everybody starts listening. Okay? Multiple CANs. Lots of multiple CANs. Second set of high-speed, common modules, power and ground, same thing. Okay? Here's a GMC, 2012 GMC. Again, you know, I'm picking older cars because they're a little simpler. If you put a diagram for a 2020 Lincoln on the screen, no one will be able to see it because there's just way too much there. So pick something older. Okay? So here's our low speed. Again, if you look at the DLC, which is mid to left on the screen, you got pin 16, you got 5, you got 4, you got pin 1. Okay? There's another low speed, or another series of 5 modules which are on the same low speed connected together. Okay? Then we have one high speed. Now this high speed, and go to the DLC, upper left. What pins? Pin 6 and 14. So this is going to be the first high speed that you'll find on cars. They're going to be pin 6 and pin 14. Okay? The enable serial data is a LIN. There's a linear interconnect on a BCM, and there's on the radio and HVAC, there's a LIN. So you've got a lot of LINs on this car. And then, now, look down. It used to be pin 6 and 14, is now pin 12 and 13. Now, this is not an either or. This is and. So in other words, you have a high-speed network on pin 6 and pin 14. You have another high-speed network on pin 12 and 13. Okay? And here's the pin out for the same vehicle. Now remember, this is 2012. Pin 2 and 3, not used. Pin 7, 11, not used. Pin 15, not used. There's a whole bunch of other things that can be put into the data link connector. And that's one of the things you'll notice. I don't think, I may be wrong on this, but I don't think there's an automobile yet that uses all 16 pins. There probably is. Anyway, so if you look down pin 6, high-speed GM LAN, serial plus. 6 mates with 14, notice high-speed serial data minus. 12 and 13 mate. 12 is plus, 13 is minus. So when you look at these automobiles, and you teach the diagnostic routine, teach the student to look at what works and what doesn't work, and then go into the wiring diagram. Okay, I think I'm probably gonna skip over some of this right now, because I think instead we're gonna go back and we're gonna go live here again if we can. Okay, the basic diagnostic procedure. And actually, I think I want to put that on the screen. So let's go. Sorry for this. If you're getting a little seasick by looking at it, I apologize. Okay. Basic diagnostic. Now, this is a part that you do on a car or you do on a trainer. I'm going to do it on a trainer just because the trainer is a little more convenient for me, and hopefully for you also. This trainer follows everything about the basic diagnostics, and you will find, engine benches. I got another trainer that I'm looking at right here, which is built off of a Cobalt chassis, and it has the same. You can use almost any of our trainers to teach CAN bus diagnostics on it. Just when you get to the end, do not have students disconnect and unconnect things. So we take a basic diagnostic and we say, we have no communication, we have a no starter or crank. Now, this is what typically brings a car in, or like Tim went through on the previous class, you have a check engine light and something else. Well, for us, I'm going to say for no communication or no start. First thing we do is we pull the battery. Now, I understand that when you pull batteries, sometimes you put some modules in parallel and they have to relearn things. So maybe you don't have to do that. You can pull some fuses, pull a CAN bus fuse or whatever. But the main thing is we want the system basically not having any current flowing through it, because we're going to ohm out the high speed. When we ohm out the high speed, then we're going to look for a wake-up signal. And here we're going to use a DSO. And you can use a single channel DSO for this. Then we're going to look for communications in something we call a mirror image. And then we're going to scan for available module or module status. Okay. I'm going to unplug my battery. I just cheated. I turned the power supply off. Okay. Now, I recognize that this is hard to see, so I may wind up having to read it to you. But what do I want? What am I looking for? Well, I'm going to go up to pin 6 and 14. Actually, before I do that, I'm going to turn the multimeter on ohms, and I'm going to zero it out. Okay. And then I'm going to go up to pin 6 and 14. And by the way, you don't have to worry about polarity or anything else. Let's see. No, can't read it. Anyway, it says 59.4 ohms. Al, you said there are 120 ohm resistors. Yeah, but how many of them are there? 1, 2. They are wired across, which is another way of saying they're in parallel. So they're in parallel in the circuit. Now, Ohm's law says the total resistance of resistors in a parallel circuit is always going to be lower than lowest resistance. Or a subset of that is if we have two resistors which are the same resistance, 120, 120, then the resistance value will be 60 ohms. Now, real nice, this is a nice part about a trainer. What happens if one of these resistors goes to lunch? I just unplugged one line. I went up to 117.7 ohms. Didn't quite go up to 120, but these resistors on cars, they bought all of the old Radio Shack store resistors when they were going out of business. So they're not a 120 ohm exactly. Okay? So the first choice I had was I had 60 ohms, didn't I? Okay? I basically have an open circuit now. I disconnected my second resistor. I basically have an open circuit. What I actually have here is 9 mega ohms. 9 million ohms on a car is like an open circuit. Okay? So let me plug them back in.
Al, while you're doing that, we had a instructor ask if LIN is a one-way communication.
Yes. Yeah.
Thank you.
Good question. Good question. I'm going to take a jumper wire and I'm going to jumper the CAN bus. And in fact, I'll jumper the CAN bus here at the junction block. Okay. 0 ohms. Now, if you think about this, I just gave you 4 choices. Those are the only 4 choices that I've ever seen. And that you're probably, I mean, there are other choices, but you're probably never going to find them. The most common choices, what's the first? 60 ohms. What does that mean? There is a communication pathway. 120 ohms. One of the resistors or one of the resistor pathways is not there. Open circuit. Neither of the resistors or pathway are there. For 0 ohms, the CAN bus is shorted. Now, you know, oh, Al, it never happens. Okay. Based on my time, I know I'm not going to get to any of these case studies. My first case study in there, though, is a case where a student of mine who's in some night classes that I'm teaching calls me and asks me to come. And anyway, we get into this, and, you know, the car won't run. Cars had recent service. What's the recent service? Nobody knows. Turns out the recent service was a bracket. This was a municipality, a bracket that was installed on the dashboard so the guy could take his meter off, his water meter, and hang it there when he was driving to the next site. Put it in. I don't know. Somebody who looked around in his toolbox and said, well, I need 2 screws here. Here's 2 3-inch deck screws. And he screwed the 3-inch deck screw all the way right smack dab through the middle of the CAN bus. Okay, so he shorted it out. So it is something you may see, you may find. Okay, so I don't screw myself up later on. Let me unplug this. I'm done with the multimeter. Now, somewhere along the line, your students have heard, hopefully not from you, but your students have heard that if they get a multimeter across a battery, you burn the multimeter out. Well, that's only partially true, right? If it's on amps, yes. But in this particular case, we're talking about measuring resistance. And the only thing that happens is you get an inaccurate reading. So if I've got power floating around in this circuit, I'm going to wind up with something other than 61 ohms. I come up with some crazy reading. I am right now floating between 143 kilo ohms and about 101 ohms. So I'm floating. So I'm going to use it. So right away, I'm going to say, oh man, I got a problem here. No, the problem is you have power. If we start shutting things down, especially if we close out the power end of it, when this thing settles down, there's 60 ohms. Once it took the system going to sleep. Okay, so it's an inaccurate reading that we're looking at. What are you actually measuring? You're measuring a bus resistance. Now, you know, somebody might say, you know, this is a brand new modern car and you're using something as old as a multimeter on it. And the answer is yes, that's exactly what I'm doing. I'm using an old school because what do I want to know? I want to have 60 ohms. What does 60 ohms signify? 60 ohms signifies that you in fact have two 120 ohm resistors that are in the circuit. You are, when you're measuring this bus resistance, you are measuring a communication pathway. If you don't have a pathway, you don't have communication. Now, does this multimeter reading here of 61.4 ohms, does that mean the system is going to work? No. Does it mean the system might work? Yes. If we have 0 ohms here, or infinity, I can guarantee you the system's not going to work. With 61.4 ohms, we're in the ballpark. There is a pathway there. And that pathway should, in fact, allow communication to occur. Okay? The key to all this is the wiring diagram. And in my particular case, I'm looking at a high-speed network. So I just went to pin 6 and pin 14. Okay? Here's a forward wiring diagram. I dare you to find the 120 ohm resistors. The thing is, they're not there. It doesn't mean they're not on the car. It just means they're not on the diagram. So many of the forward diagrams, not all, but many of the forward diagrams do not show the 120 ohm resistors. Okay? So again, what are our choices? 61 ohms, and that is in giving us basic information on opens and shorts. Do we have a path? This fourth bullet might be the cause of no monitors. In Illinois, we do mandatory vehicle emission tests for vehicles that are 4 years old until they become 20 years old. So we test a hell of a lot of cars. And those cars, it's a plug-in test. And when we plug in, we need to see that the monitors have run. And if there's no DTCs, the check engine light is off. That's the 3 criteria of a pass. We find if you've got 120 ohms, does the car still run? Yeah, most of the time. Does it run well? Yeah, probably. Would the customer even know it? Maybe not. But now he goes through his emission test, he plugs in, and that's when they realize, hey, none of the monitors have run. Sorry, go get the monitors to run and bring it back. It's either going to be a reject in some states, or it's going to be a fail. So it's a very, very common cause of no monitors. After the digital multimeter, we reconnect. Okay, now we're going to switch to a DSO. Now, in an effort to try to make sure that I didn't overload my system, I have not had the DSO running, so I'm going to start firing it up right now. And then once I actually have the DSO, and I'll be using a Pico in this particular case. I'm not, by the way, I'm not saying that Pico is the best or the worst or anything else, but you know, it's a 2-channel. I have a 2-channel Pico, and it's an interesting component, an interesting system to use. And the other thing about it is, you can use the Pico 6 automotive software even if you don't own a Pico. Dick, is my Pico on the screen?
Yes, it is, Al.
Okay, all right, thank you. It was silence there, and it was like, oh boy, I'm talking to the garage wall maybe. Anyway, let me just go real quickly through. The Pico 6 automotive software, even if you don't own a Pico, you can go online, you can load it. Once you load it, you run it in, it's like a test mode. I can't think of it.
Demo mode. Demo
mode, thank you. Yeah, I knew you knew it. Okay, in demo mode. Once it's in demo mode, if I go up and I touch on automotive, I come up with a whole bunch of things. I'm going to touch sensors, and I'm going to say, oh, okay, crankshaft, and I'm going to look at inductive, and I'm going to say running. Now, what it's doing is it's going and it's picking out in its memory this particular sensor. Again, remember, you don't have to own it. Okay, you just own the Pico 6 automotive software. This is taking a while to run because of everything else that to load because of everything else that I have got running. And it might, okay. Now, this gives me an idea of how it works. And if you go down, there's how we connect it. Okay. Here's how it works, utilizing 2 wires. And then there's a diagram. So even if you don't have Pico, you can use some of the Pico software.
Thanks.
Oh, I didn't want to do that. This again is the 2 errors, human erase, screw up, you need a computer. I hit the close button and I didn't mean to do that. So Pico has to come back in. And while it's loading, let me talk to you about what we're going to do. Why do we use a DSO? We use a DSO because, first of all, the signals that are coming from a CAN bus system are extremely, extremely fast. Okay? Now, I'm not going to switch to the camera, but what I'm doing is I'm turning on the power supply. Now, those signals are, you know, they're coming by real fast, but what's happening here is these are a series of packets, okay? The packets are going, and an interesting thing about this, and something that we'll have to probably diagnose, I'm going to turn off my wake-up signal. The system went asleep. Now, as soon as I turn it on, the first blip that goes across, right there, that blip was the wake-up signal. And what you can do with this, for student standpoint, is you can say, okay, can we capture this? Yeah, we can go like this, and we can take this, and we can bring it up to, let's put it about there. Yeah, that'll do it. Okay, now, I'm going to put the system to sleep. And once the system goes to sleep, and I can see it by looking at it, then I'm going to start. Now, the reason there's no pattern on the screen is because nothing has happened. The next thing in sequence here, we started out with the ohm meter. And the next thing is to teach the students how to look for a wake-up signal. Okay? So right now, I'm going to go up. I've got my oscilloscope set, and I've set trigger for single, and I've set my trigger level for about 2 volts. Okay? And I'm going to go up and I'm going to hit the wake up switch. Okay? Notice I got a pattern. I got one little blip over here. That's actually the wake up signal. Now, if I get rid of this, let me go back to auto here. Okay? Now I'm going to lock it. Okay? Because I want to look at this. So I'm going to go up and I'm going to pick up my expand, and I'm going to expand just this. Okay? Now, you might look at that, and if you're not a Pico person, recognize that what I did is I just used this zoom feature, and it allows me to open up the system and look more carefully at the individual signals. I'm noticing an awful lot of noise on this, so I'm going to go up to A, and I'm going to activate some low-pass filtering. Okay? And then I'm going to take it up. That'll be good enough. Okay? So that's a packet of information. What's a packet? Well, a packet is a series of on-offs with little blips and a few other things thrown in, which are part of the communication protocol. So right now the system is communicating, and it's communicating on this, and obviously the system is on. So we had a wake-up signal. Now I'm going to flip back over to PowerPoint, because there's a wake-up signal on a low speed on an actual car. It may even be a little simpler for a student to understand. What I like to do is I like to say that when you look at the signals on our trainer, the signals will be in fact on-off signals, but they might not look exactly like they are in a car because this vehicle of ours only has 4 electronic modules. It doesn't necessarily have 4 car modules. Okay, let's go back to Pico, and let's open up. Okay, there, that's a little better in terms of on-off signals. Now, I am on CAN low. How do we know I'm on CAN low? The signal starts high and it goes down. So the first thing was ohm out, looking for 60 ohms. The second thing is look for a wake-up signal. The third thing, and probably one of the most important things, is going to be the next thing we want to do is we want to look at what we're referring to as a mirror image. So I'm going to go up and I'm going to turn on B. Okay, and I'm going to connect B. All right, let's spread them apart a little bit. Okay, now in reality, the way that it showed me is probably the most accurate. In other words, it's actually like this. Okay, but it's a little harder to see that way. So I'm spreading them apart. Okay, and then I'm going to freeze it. And after I freeze it, I'm going to zoom it. Okay, and I'm going to look at this. And the first thing I realize is this is really tough to see. So let's move this out of the way. Okay, I'm going to put some filtration on. Okay, whatever filtration, low pass filtering, you put on channel A, you have to also put the same thing on B, otherwise it isn't going to look right. Now, what we're looking here is for communication, where communication occurs in a mirror image format on the CAN high and CAN low. Okay? CAN low is on top, signal goes high, it's pulled low. CAN high is on the bottom in red, where the low signal is pulled high. If you look at these, and I can make them really close together, I mean, that is absolutely, without a doubt, a mirror image. Do you agree? Now, just so you see, now the silence you heard was me putting in let's move this up. Not that far. Let's go to 40. And let's go to, again, you always match. Okay. Now I'm going to stop it. I'm going to expand it. Okay. This may be a little hard to see. But the question I ask you, is this a mirror image? And the answer is, for quite a bit of it, it is a mirror image, but for some other pieces, it's not. Well, let me, okay, time out here. Okay, that's live again. Now what do you think? Is that a mirror image? Here, let's zero in. Let's zero again. It's not a mirror image anymore, isn't it? Does the pattern follow one another? Well, the answer is yes. But this is what happens on an automobile with a bad module. Now, I just put in a bad module, and that's something I'm not going to spend the time doing, but I'm able to put in a bad module. If you see this on a car, the car might still be functioning, because if I go up to this with this problem in it, okay, now, I just turned on the backup light. Notice, backup light doesn't work. In other words, whatever this problem is, it has shut down a module. Does anything work? Doesn't look like anything works. So it has shut down the whole system. That's what this error did to it, okay? Because if we get rid of the error, brake lights, okay? The key here is to have the students recognize that once the signal is awake, then if we put CAN high and CAN low together, and we get them close enough, we will have a mirror image if the CAN bus system is in good shape. If there's a problem with the CAN bus system, then I showed you, you wind up with not a mirror image. It may track and follow one another, okay, but it's not the same thing. I usually like to go up to the first person in the first row and say, "Can I borrow your cell phone?" I don't even have mine out here. But when you connect to an automobile with a scanner, what's happening is the high and low signals are doing this. Okay? When there's a bad module in it, it interrupts, and now all of a sudden they may follow one another, but they're not in sync with one another. And you're looking for them to be in sync, not follow. Now, back up one here, and maybe Dick, this is a good spot if you've got some questions or whatever, before I go into the scanner part of it.
So far, we're good. I think we have some instructors that may want to discuss Lynn with you when we're in the Q&A session, but go ahead.
Okay. Okay, so now back up. What did we do first? We ohmed it out. Then we look for the wake-up signal. Then we look for the mirror image. Important, teach the student to stop if something is not right. You don't go and look for a wake-up signal if you don't have 16 ohms. You don't go and look for a mirror image if the system doesn't have a wake-up signal because it's not on. Okay? The last piece of this involves using a scanner. Now, I'm a cheater, have been all my life. I use the simplest vehicles. If you want to teach CAN Bus, you can, by the way, this is all available in the handout. So these individual items, you know, these individual slides are available there. Feel free to use them. We'd love it if you gave ConsuLab a little bit of credit, but you know, the important point is I have chosen the simplest. This is the simplest CAN Bus vehicle made. Now, obviously, it's not on the road much anymore. 2008 Pontiac Solstice. What do we know about a Solstice? First of all, it's extremely simple. There's your whole low speed, the entire low speed system. Here's your entire high speed system. Okay? Now, this is a good one to take note of. In the upper left-hand corner here, see where that 120 ohm resistor is? Notice it's just on the wires just in back of the data link connector. I worked on a vehicle, it wasn't a Solstice, it wasn't a GM, I think it was a Suburban, where, you know, it wouldn't run anymore, and we wound up realizing that in the process of driving the vehicle, the owner had kicked the resistor and disconnected one leg of it from the connector, which is on a twisted pair. So, you know, the position of these things is not necessarily the best thing. They're everywhere. We were looking for one once on not an Equinox, might have been an Equinox anyway. And the student, and I said, okay, find it. You know, I'll use a wiring diagram. He said, well, according to this, it's on the frame rail, rear of the car. And I thought to myself, oh, I don't know if that's right. Kid got a creeper out, stood under the car, came out holding this terribly corroded, because remember, I live in Illinois and we love salt. So all winter long, we throw salt on the roads to melt the snow and eat the cars away. That connector was so bad that we wound up having to clean it as much as we could, repair one of the pins, plug it back in, everything was fine. Okay, when you first plug in a scanner, and I'm going to use Auto Ingenuity here, just because it's one that'll show up on the screen reasonably well, automatically the scanner goes into the gateway and tells the gateway, please ping the modules and let me know what's here. So it's all part of the startup procedure. And the next thing is you wind up with a series of things. And what it says is tells you whether there's any diagnostic codes, like the first one, generic powertrain, no diagnostic code, enhanced powertrain, no diagnostic transmission, etc. And you wind up with 2 full pages. Now, this is where this next procedure becomes really difficult to do. Not impossible, but difficult to do. And for this, what I've done is I go back to my Equinox. So I asked the student to try to determine what they actually have prior to connecting. Use the breakout box. Have a wiring diagram. Keep the damn hood down. We don't need anybody messing around with under the hood or anything else. Okay? Pay attention to details. First thing that happens is the scanner says, requesting module status. What does this mean? Well, this means the gateway is saying from the scanner, hello, hello, is anybody listening? Is anybody talking? And it's also asking the question, is anybody having a DTC? So on my simple car, and these are actual, by the way, you can't make this up. I mean, this is actual. I had a son-in-law who owned one of these Solstice, and once I realized that it was the simplest car in the world, he wound up driving my car and I drove his, because I just used it a lot in my classes that I was teaching. Module status, so back up. First thing is, you see on the scanner requesting module status from the vehicle, please wait, okay? Now, here's module status. And this says that there are 1, 2, 3, 4, 5, 6, 7, 8 modules. And these 8 modules, none of them have any DTCs. So what the scanner says is, hey, I asked a question, I took roll call, just like my teacher always used to do. I took roll call, and when I took roll call, I had 8 students here, and they all raised their hand, and they all did their homework. All right, so we're in great shape. This indicates that communication is occurring. We have 8 modules present. Now, what if there's actually 10 modules on the car and 2 of them are disconnected? So here's where we go to the wiring diagram. We have no DTC. Here's the wiring diagram. Count the modules, please. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 modules, and the vehicle scanner says there are 8 modules. So is the system functioning? Yeah, this particular one is. Now this is low speed, because you'll notice it's on pin 1. The key here is to get a module status. Once we have module status, compare it to actual. What does the scanner say on module status? And then what does the wiring diagram say? So we back out of this and we go over to dual wire. Once we get the dual wire, we hit enter and we have exactly the same thing happen. Does communication occur? If it does occur, what modules are on this bus? Any DTC? So here's again, this is our 2008 Pontiac Solstice. We have 5 modules. You see why I use this car? There are 8 modules on the low speed and 5 modules on the high speed. Not many at all. As opposed to, I scanned a vehicle, a Chrysler product, that it was close to 90 modules. I forget exactly. Anyway. Okay, so I have an indication that communication has actually occurred. I have 5 modules. One of them has a DTC, and for this, our purposes right now, I don't care about it. But anyway, you can see what happens when that radio at ECU 0549, when it reports in, it says, I'm here, I got a problem. Okay? Now we had 5. Here's your diagrams again. 1, 2, 3, 4, 5. Is everything balanced? Does it make sense? Sure. We have 5 modules saying we're here, and there's 5 modules on the wiring gun. We're supposed to have that. Okay? Piece of cake. So, this testing sequence review. We have no high-speed communication. Disconnect the battery. Measure resistance between pins 6 and 14. Or, if you have multiples, they got 12 and 13, do 12 and 13 also. Got to be correct. Fix it. We look for a wake-up signal. Once we're sure we have a wake-up signal, then we use a dual channel, and we look for high and low signals, and they should be a mirror image. If they are not a mirror, again, you stop wherever it's not right. The last thing is we check for module communication. If there is no module communication or there's a problem with the mirror image, we go to the individual module. We check for B+, B-, and signal. Repair is needed, replace, reprogram, whatever. Now, you can teach disconnecting the battery, measure the resistance, wake-up signal, and mirror image on a car with a breakout box and never need worry about doing any damage at all. If the student stays away from the module and does everything at the breakout box, they will not or cannot do any damage, even if they short terminals together, okay? With the exception if they short 16 to 5, they're going to blow a fuse, okay? But that's not going to prevent the car from running. All right. Module versus wiring diagram. Now, there are some questions on the LIN, so let me real quickly, and then I'm done here, okay? If you go to a LIN module, recognize that a LIN module is going to be turned on by something. So typically all we need is a voltmeter. Check for power, check for ground. There is no signal. So if it's a fuel pump module and the fuel pump doesn't want to work, we go into the fuel pump connector, we unplug it, we put a multimeter, or you can even use a low current test light, and we put it in there and we turn the system on. When we turn it on, remember, in my example, the body control module tells the LIN, or tells the fuel pump module through the LIN that you have to turn on. And all it does is it supplies power and or ground. So if there's power applied to the connector all the time, it applies to ground. If there's a ground all the time, it connects power. And there are some brand new cars that disconnect and reconnect both wires, both power and ground. Okay? And then, of course, we have to recognize if, in my example, if the fuel pump module doesn't work, well, the reason it might not be working might be that the BCM is not working. So the diagnosing the LIN might be the first thing you go to if you have, for instance, a bad fuel pump, no fuel, no start. But it might be the last thing you look at because it's being controlled off of something else. Okay, both ends need to be checked. Okay. You can tell there's a few slides here I haven't gone through. Okay, we've done this, but let's make sure everybody understands it. I'll put it all up again. Okay, Got to do it in sequence, people. For mirror image, expand the screen out so you can clearly see it. If there is a lack of a mirror image, key off, disconnect the most convenient module. So, you know, this is where the trainers work out so much better. Recheck for mirror image. So do not disconnect the module with CAN Bus up, because even if there was nothing wrong with that module, there may be now. We have two trainers, one of which is an MP750, which is a Honda. You can see it's got doors, it's got a dashboard, it's got headlights, taillights, it's even got a radio. So there's a whole bunch of modules here, and these modules are wired with special connectors which allow them to be connected and disconnected. Okay, this is the only trainer that has all the modules fully, okay, diagnosis with the special connectors. And this one will allow you in a class to connect and disconnect. Take your time and always plan ahead. I'm not sure you're hearing the audio, but there's our astronaut. Whoops, the door closed. And oh my, where's my key? I forgot the key. Take time and plan ahead, obviously. Listen, I'm a sailor. Sailors wish other sailors fair winds. More than an indication we want to have you have good weather. It's that everything works well for you. Hope to see you at another conference or maybe on the water. I want to thank you for attending. Okay? And think of ConsuLab next time you need equipment, because we're there. Dick,